So, hello everyone. I am Nikhil Saraswat. I am final year undergraduate student of Department of Computer Science and Engineering at IIT Kharagpur. So, today's topic is the linear programming. So, so basically this topic includes ke in this there will be an expression for example just take a question. Okay. Mm, just a second. Okay. Like for example, this one is a question. So here we have to maximize this z, which is the 4x plus y, and these are constant related to this problem, like the x plus y less than equal to 50 and 3x plus y less than equal to 90 and x is greater than 0 and y is greater than 0. तो इसमें क्या है कि कुछ कंस्टेंट्स दिए हैं जो एक्स और वाई दोनों वेरिएबल्स हैं उस पे, और एक एक्सप्रेशन है जो कि उन दोनों वेरिएबल्स को इंक्लूड कर रहा है, और इस एक्सप्रेशन की वैल्यू को मैक्सिमाइज या मिनिमाइज करना होता है। लाइक दिस टाइप ऑफ प्रॉब्लम इंक्लूड दिस टाइप ऑफ क्वेश्चंस होंगे। ओके, तो इसमें कुछ कांस्टेंट होंगे और उसमें से एक पर्टिकुलर एक्सप्रेशन को मैक्सिमाइज या मिनिमाइज करना होगा। तो इसमें बेसिकली फर्स्ट ऑफ ऑल के जो कॉन्स्टेंट्स हैं उनको एज ए ड्रॉ किया जाता है किसी ग्राफ पेपर पे एक्स और वाई एक्सिस पे। तो इसमें जैसे कि ये इसमें ड्रॉ किया गया है एक्स प्लस वाई लेस देन 50 को और 3x प्लस वाई लेस देन 90 को। ये जो 3x प्लस वाई है और ये x प्लस वाई इक्वल टू 50 है। इसके बाद एक्स ग्रेटर देन जीरो, एक्स ग्रेटर देन जीरो इंक्लूड्स के इधर का पूरा पार्ट है वो सब एक्स ग्रेटर देन जीरो आ जाएगा, वो बाई ग्रेटर देन जीरो इधर वाला पार्ट है। अब चूंकि इसमें देखना है कि लेस देन मतलब अब एक्स प्लस वाई इक्वल टू 50 वाला लाइन ये है, तो अब इसमें लेस देन और ग्रेटर देन वाला कौन सा है वो उसको डिफाइन करने के लिए जस्ट टेक के कोई ओरिजिन को इसमें पुट करके देखो। तो इफ वी आर टेकिंग ओरिजिन 0,0, then 0,0 that will result in 0 that is less than equal to 50. सो इधर वाला जो इस लाइन से इधर वाला जो पार्ट है जो बिलो वाला पार्ट, दैट विल बी द पार्ट ऑफ दिस रीजन। एंड सिमिलरली फॉर दिस, इसमें 0,0 अगर पुट करते हैं तो बेसिकली दैट विल बी 0 विच इज लेस देन इक्वल टू 90। तो इसका भी जो इस लाइन से जो लोअर वाला पार्ट है दैट विल बी द पार्ट ऑफ दिस रीजन। सो एक्चुअली टेकिंग कॉमन रीजन ऑफ ऑल द कंस्टेंट्स, दिस इज द पार्ट। नाउ वी हैव टू मैक्सिमाइज दिस एक्सप्रेशन 4x प्लस वाई। तो देर आर 4 पॉइंट्स। तो पहला वाला है 0,0, दूसरा दिस वन 30,0, तीसरा है ये वाला 0,50 एंड द फोर्थ वन इज द intersection of these two lines. So we can find the intersection of two lines which is including two variables easily. So that will be 20,30. Now expression will take its maximum or minimum value at these 4 points only. So we have to just check the value at all the points कि 0,0 पे 4x plus y का वैल्यू that will be 0 and 30,0 पे a 4x plus y का वैल्यू that will be 120 and at 20,30 the value will be 110 and at 0,50 the value will be 50. So we can clearly see कि 120 is the maximum value out of all these four values. So that will be the maximum value of this expression. Okay. So this is the method to solve all the problem which include the linear programming. There the expression will be given which we have to maximize or minimize, and there will be some constant related to that expression, and using those constants we have to maximize or minimize the value. Okay, so now just come to the exercise. Okay, so this is the first question, in which we have to maximize this expression where z equal to 3x plus 4y and the constants are x plus y less than equal to 4, x greater than 0 and y greater than 0, greater than equal to 0. Okay. So first of all, we will try to draw the graphical representation of these constant. What does it mean actually? Okay. So x plus y less than equal to 4. So just draw this line x plus y equal to 4. Just try to draw this line. So for x equal to 0, if we put x equal to 0, then y will be 4. So for x equal to 0, suppose this is the x-axis and this is y-axis, and then add x equal to 0, the value of y will be 4, and for y equal to 0, the value of x will be 4. Okay, so this is the line x plus y equal to 4. Okay, and x greater than, now the x plus y less than equal to 4. So for that we will try to put the origin इसमें put करके देखेंगे, तो like at that time is it satisfying or not. So 0,0 अगर इसमें put करके देखते हैं तो 0 plus 0 that will be 0, then that is less than equal to 4. So 0,0 is a part of this region. So like actually this line is dividing the whole region in two parts, and 0,0 is satisfying the region. So the below part, like this one, this will be the part of the equation. The second constant is x is greater than equal to 0. So this is the x-axis, and this is 0,0. And if we go in this direction, then in that direction x will be greater than equal to 0. So we are excluding this part, we are just taking this part only. And y greater than equal to 0, so y is axis is here, and above this 0 y will be positive. So finally, if this is the region which is a part of the constraints, okay, this is the region. Now इसमें तीन पॉइंट्स हैं. The first point is this one, 0,4. Second point is this one, 4,0. And third one is this 0,0. Actually this is a triangle, and triangle के like three इसमें points हैं. On these 3 points, the expression will take its maximum value. So we will just check the value at each point. What is the value? Okay. So at 0,0, at 0,0, the value of 3x plus y. So it will be 0 into 3 plus 4 into 0. That will be nothing but 0. And at 0,4, at 0,4, 0,4, this will be like x की जगह अगर 0 रखते हैं तो that will be 0, and 4 into 4 that will be 16. So this is 16, and at 4,0, like y की जगह पे 0 रखेंगे तो 4 into 0 that will be 0, and 3 into 4 that will be 12. Okay, so there were 3 points, and we had to find value on all the points, and then we have to like determine which is the maximum out of these 3 points, all the 3 points of this constant, like this area actually. So here we can notice that this 16 is the maximum value out of all the three. So we were interested in the maximum value of this expression, and that is 16. So this is the answer of this question. Now we will solve the second question. So the second question is, we have to maximize this expression by using these constants. Okay. First of all, we will draw the constants on the 2D plan. So first of all, this line x plus 2y equal to 8. X plus 2y equal to 8. So at x equal to 0, y will be 4. So at x equal to 0, y will be 4. That will be somewhere here. And at y equal to 0, x will be 8. So that will be there. Actually, like we are not taking exact scale, but like something. It could like reflect in a similar kind of data set. Okay, this is the line that is x plus 2y equal to 8. Now drawing second line, that is 3x plus 2y equal to 12. Okay, so we are not taking inequality at this time. We are just taking equality and just drawing the lines. After that, we will determine which region is a part of this inequality, or like which region is not a part of this inequality. So first of all, just put x equal to 0. Then y will be 6. That will be somewhere here. And at y equal to 0, x will be 4. So that will be somewhere here. So this line will be drawn like this. So these two lines are intersecting at this point. So we have to determine like which point is it. So for that, we will find the intersection point of these two lines. So for finding intersection, we will eliminate a variable. So just multiplying the first equation with 3, that will be 3x plus 6y and equal to 24. Subtracting the second one from it was 2y equal to 12. Just subtract this equation. So, so this will be 4y equal to 12. That is nothing but y equal to 3. And if we have y equal to 3, so if we will put this y in any of the equation, then that will give us the x. So like putting this 3, y equal to 3 in this below equation, that will be 3x plus 2 into y will be 3, the 2 into 6 equal to 12. And 12 minus 6, that will be 6. And if we divide the 6 by 3, then x will be 2. So the intersection point is 2, 3. Okay. Okay, now determine the region. So first of all, the first constant is this, x plus 2y less than equal to 8. So if we try to put origin, because origin is easy to verify. So if we put the origin, then we can take any point, but like the verifying origin is like easier in this case. So if we put the origin in this inequality, then that will be 0 plus 2 into 0, that will be 0. That is less than 8, less than equal to 8. That is satisfying this inequality. So like actually this line is dividing the plane in two parts, this below one and this above one, like the upper one. So, but the origin is coming like satisfying this inequality, and origin is in this part. So like this, our like desired part will be the below one for this inequality. And for the second inequality, if we put origin in this equation, then that will be 0 plus 0, that will 0 less than equal to 12. So like yeah, this line is also dividing the plane in two parts, but the actual desired part will be this below one. So and we have to take the common of these, like this is like the part which is which we are taking by using this line, that is this one, this whole. And in this line we are taking this part, so we have to take the common part, so common part will be this one. And here another constant is x is greater than equal to 0, and y is greater than equal to 0. So x greater than equal to 0 will be in this direction, and y greater than equal to will be in this direction. So the actual desired part will be this one. The shaded area is the part in which we have to maximize our expression. So there are 4 points. So first of all, the origin will be there, like the 0, 0 is here, and this is 4, 0, and this is 0, 4. So first of all, we will check at 0, 0. So what is the value of the expression at this point? So at 0, 0, it is like the expression minus 3x plus 4y is given 0. And at 4, 0, if we put x has 4, so that will be minus 3 into 4, minus 12 plus 4 into 0, that will be minus 12. And at 2, 3, this will be minus 3 into 2, that will be minus 6 plus 4 into 3, that will be 12. So overall this will be plus 6. Then and just a second, just take it here. Add 0, 4. This will be placing 0 at this place and 4 at this place, so that will result in 16. And we are interested in the minimum value, but we are minimizing this expression. So we can clearly see like this is the minimum value of this expression. So minus 12 is the answer of this question. Okay. So the third one is similar to this only, because here we have a similar expression and we have a similar kind of constraints which were there in the second question. So like third one is similar to that. And yeah, fourth one is also like similar because it is also including constraints and expression to minimize. Okay. Just a second. But like we can try it. So what the fourth one is saying, see, expression is this one, cs plus 5y. We have to minimize this one, and the constants are these. Okay. So drawing the first line on the plane. So this is the plane, and the first line is saying x plus 3y. Just take equality now. Working out, and we will take inequality afterwards. और इसमें x plus 3y equal to 3. अगर इसमें x equal to 0 रखते हैं then that the y will be 1. So 1 will be somewhere here. Just a second. Yeah. Y will be somewhere here. And if we put y equal to 0, then x will be 3. That will be somewhere here. No, so this is the line joining these 2 points. We can draw a line by using 2 points in the front. Second equation is x plus y equal to 2. Now at y equal to 0, x will be 2, and x equal to 0, y will be 3. The line joining these 2 points will be 2. Okay. So now we will find the intersection point of these 2 lines. So post finding an intersection, we can simply subtract these 2 lines. So if we are subtracting these 2 lines, then x will cancel out and 3y minus y will be 2y. Just a second. 2y equal to 1. So y will be equal to 1 by 2. And then if we put y equal to 1 by 2 here, and if we will subtract 2 minus 1 by 2, so x की value होगी 3 by 2. X will be 3 by 2. So the intersection point is this 3 by 2 on 1 by 2. इनका intersection point है. Now we will check whether which region comes in in each of the constraint. Okay. So first one it is x plus 3y greater than equal to 3. So we will repeat our process, like we will try to put origin in this inequality. If we put 0, then इस साइड में होगा 0 and इस साइड में है 3 and 0 is greater than equal to 3, that is false. So 0 is not coming in this region. So like the line is dividing the plane in 2 regions, but 0 is not coming. So like the upper part will be the part of this constraint, the upper part of this line, the upper part. And we take the second one, x plus 2y greater than equal to 2. और इसमें भी अगर 0 0 put करते हैं, then 0 is greater than equal to 2, that is also false. So इसका भी जो upper part है, that will be the part of the constraint. And x comma y greater than equal to 0, so like x comma y greater than equal to 0, that will represent the first quadrant. So overall, this is the desired part of this region, this above one, which is satisfying all the constraints. The desired part is this one. The part is in first quadrant and above all both of the lines. Now there are 4 points. Oh, there are 3 points. The first one is this intersection, second one is this, and third one is this. So if we want to minimize our expression, so we have to check the value of the expression at all these 3 points. The first one is this intersection, and second and third is this one, this intersection of this like y-axis with this line, intersection of this x-axis with this line. Okay, so I write down all the points. So first one is this one. So that is 3 comma 0. Second one is this intersection 3 by 2 comma 1 by 2 is to say. And the third point is 0 comma 2. Now check the value of the expression, this expression, or on all the points. So if we put 3 comma 0 in the expression, so the value of the expression will be 3 into 3, 9 plus 5 into 0, that will be 9. And on this point, 3 by 2 into 3, that will be 9 by 2 plus 5 by 2. That will be nothing but 9 plus 5, 14 by 2, that will be 7. And if we put this 0 comma 2 in this line, then that will be 3 into 0, that will be 0, and 5 into 2, that is 10. But we are interested in minimizing this expression. We have to minimize the expression. So minimum value will be this 7. So for finding the minimum value or maximum value of any of the given expression in a given constant, first of all, we have to just find out the shaded parts which comes under the constant, and then we have to check the intersection points of this shaded part, and we have to check the value on all the intersection points, and then we have to determine which is like the which value is the maximum or which value is the minimum. Okay, so the fifth one is similar to this only. Sixth one is also like similar to this. So we will just like in the fifth or sixth, the same expression is given, a different expression like, and the constant is also given, which we have solved in the second or third. And then sixth one, the constant are given just similar to this fourth one. So we can solve this using the same similar process. So now we will solve this seventh one. So seventh question is saying that we have to minimize and maximize z equal to 5x plus 10y which are subject to like these constraints. Okay, so we will draw the constraint first, then we will think about the maximum minimum values of this. Okay, so just a second, draw the constraint first. Okay, so the first line is x plus 2 by equal to 120. So we put y equal to 0, then x will be 120. So that will be somewhere here. Just take it, this one, 120, comma 0. And if we put x equal to 0, then y will be 60. That will be somewhere here. That is 0, comma 60. And we join these two points. Now the second line is x plus y equal to 60. So if we put y equal to 0, then x will be 60. That will be somewhere here. 60, comma 0. And if we put y equal to 0, then x equal to 0, then y will be 60. That will be here. So this line is this. The third line is x minus 2y equal to 0. So at x equal to 0, y will be 0. So this line is passing through origin. Now for finding a second point, we have to put something else. So like if we try to put x equal to 60 here, then at x equal to 60 by that's just at x equal to 60, this will be like this. And at that time y will be 30. So y will be 30 will be somewhere here and x equal to 60 is here. So this line is passing through this. So now check the region which comes under these constraints. For first one, x plus 2y less than equal to 120. So if we put the origin in this line, then that will be 0 less than equal to 120. So like, yeah, origin is coming in this line. So this is satisfying this inequality. So this will be this part, lower part. And for this one, if we put 0 comma 0, so 0 comma 0 greater than equal to 60, that is false. So origin is not coming in this. So like this is taking the upper part. So it is just showing this one, this middle part of these two lines for now, this middle part. Okay. But if we take the third one, so here we can't put origin because origin is a part of this line. So we have to put some other point. So if we put this 120 comma 0, so if we put 120 comma 0, so 120 minus 0, that is greater than equal to 0. So yeah, 120 comma 0 is a part of this line. So the lower part of this line, lower part will be this one. This that is part of the constant. So actual constant is this one. And x comma y greater than equal to 0 just showing it. This will be in the first quadrant. So this is the actual constant. Okay. So now first of all we have to find these 2 points. These 2 points, those are the intersection point of this line with these two lines. So first of all, if we subtract this line with like from the first line, so it will give the, if we subtract the x will be cancel out, so the 4y will be equal to 120. So that is y equal to 30. Okay. So y equal to 30 is there. And if we put y equal to 30 in this line, so x will be 60. X will be 60. So this intersection point is 60 comma 30. Now we will find the intersection point of this with this line. So if we subtract this line with this one, so that will be x will cancel out and this will be 3 by equal to 60 by 20 and x will be 40. So this point is 40 comma 20. Okay, so we have all the 4 points of this area, this shaded part. First one is this one, second is this one, third is this one, and fourth is this one. So we have to find the minimum maximum value of this expression. Okay, so for finding minimum maximum value, we will just check the values at all the 4 points. Okay, so first of all, value at 60 comma 0. 60 comma 0, it is giving, at 60 comma 0, it is giving 60 into 5 plus 10 into 0, that will be 300. And at and at 120 comma 0, 120 comma 0, it is giving 120 into 5, that is 600 comma 0. So that will be 600. And at 40 comma 20, at 40 comma 20, if we put 40 here, so 40 into 5, that will be 200 and plus 20 into 10, that will be 200. So we will sum up both the values, then that will be 400. And at 60 comma 30, the value will be 60 into 5, that is 300, and 30 into 10, that is 300. So that will be 600 over there. So now we have to determine which value is minimum, which value is maximum. So as we can see, that 300 is a minimum value. So minimum value is 300, but there are two maximum values, 600, 600 are at two places. But we have to find only value. So the maximum value will be 600. Either take this one or either take this one. So at both the points, there will be two maximum values. Okay. So the maximum value is 600 and minimum value is 300. That is the answer of this question. Okay. Okay. So this is the solution of this question. Just a second. Okay. So just a second. Now we will solve the final question. Like these 8 and 9 are similar to this one. We have to determine the region. Then we have to check the value of at all the intersection points, and then we have to determine which value is minimum, which value is maximum. Now we will solve the final question, that is the 10th one. It is slightly different. So just a second. First of all, in this question, we have to maximize this expression z equal to x plus y. The constants are x minus y less than equal to minus 1 and minus x plus y less than equal to 0 and x comma y greater than 0. X comma y greater than equal to 0 just showing that the shaded part will be in the first quadrant and these are the two other constants. Okay. So first draw the shaded part which comes under the constant. Okay. So first line is x minus y equal to minus 1. So at x equal to 0, y will be 1. So that will be this one, 0 comma 1. And at y equal to 0, x will be minus 1. And that will be somewhere here, minus 1 comma 0. And this is the line going in these two points. Now we take the second line, that is minus x plus y. Plus x plus y equal to 0. So if we put 0 comma 0, then that is satisfying the plan. So 0 comma 0 origin is a part of this plan. So you will try some other point. Just put some like x, like 1 comma 0. So at x, like if we put some like x equal to 1. So at x equal to 1, at x equal to 1, if we put this one, so y will also be 1. So that is somewhere here. So this will be 1 comma 1. Now, and this line is passing through origin, so that will be 0.0. Now this line is sent through these two points. Now we have to find the constants, like which part is the part, and which half is the part of this constant. So in this line, if we put origin, then 0 minus 0, that will be 0. That is less than equal to 0, less than equal to minus 1. That is false here. So the upper part will be the desired part. This line. And this line is passing through origin, so we will have to put some other points. So if we put this 0 comma 1, so just try it. At 0 comma 1, that will be 0 plus 1, that is less than equal to 0. So this is not satisfying this one. So this point is not a part of this, like the half by using this line. So the lower part will be the desired part in this case. So here we can see that there is no common region in these constraint. This constraint is saying that we have to take this part. We can't take any of the point in this part, in the lower part. And this constraint is saying that we have to take only these points which come under this part. We can't take any of the point which are above this part. So there is no common region in these two parts. So if we will go for maximizing this expression, so there will be no point on which we can just get any value because the constants are just opposite of each other. So there will be no value of this expression. Okay, so in this case, this was slightly different because there was no common region as okay. So the answer of the question will be there will be no region where we can find any maximum value. Okay. So this was the topic we covered the linear programming. So here, first of all, we have to find the desired region in which with all the constraints are satisfied. Then we have to just check all the values of with check the value of the expression on all the intersection points. Then we have to determine that which is the maximum, which is the minimum. Okay, that's it.